Oh, it's too early for internet videos. So, just a word of warning here, the frame rate is really bad for the intro here that I shot, because I had that strobing light on the curtain behind me and it freaked the camera out somehow. Sorry about that. This is a really packed week. I didn't have time to reshoot it, but it does clear up after the first couple minutes. Anyway, here we go. Went to bed at 2 and woke up way too early. But this is the promised second part of this video. Now, I filmed this yesterday, the bulk of this yesterday when I did the video that I just posted, and like I said there, I decided to cut it up so that I could have comments on two different sections, because that first video was soliciting questions from you guys on some projects that I listed on some what you want me to see tests there, and this section is just me talking about like things that I've tried in various projects that just like didn't work, or other things that are related to that, some completely unrelated projects or whatever. I thought that would be interesting. Oh, my email's blowing up. Shut up. I forgot to mute it. But I thought that would be interesting because a lot of times the results you see on these internet videos are just the successful things. So it's helpful to see the process along the way and to show you all the things that like I've screwed up, and maybe some of you have experience with this and you've actually gotten it to work properly, so you could just kind of, post underneath if you're like, hey dummy, just do X, Y, and Z and it'll be fine. A lot of times you learn from failures more than successes, so I'm ripping you guys off if I don't show you the things that I screwed up. I just realized that there's this crazy strobing effect here from my window fan. Ooh. Anyway, the editing on this video might be a little choppy because I cut out the parts where I was going around fishing for thingamadoos and who's and what to show on the camera, but that's fine. I'll make it as smooth as I can. And then I decided today to go back, or I will, in the future, go back and put a conclusion at the end of each of the segments that I did to say like, hey, this is what I think of this and whatever. I'm not awake enough yet to talk. I'm going to have some coffee. Oh, and I decided to do this series and probably a couple other sillier videos in the next week or so, because I mentioned that I had an injury and had to go to the hospital and the doctor and all that stuff. And I probably shouldn't have said that without explaining it. It's nothing like life-threatening or anything like that. But without revealing too much to strangers on the internet, after decades of like every type of sport that I could do in like high school and college, plus like extreme mountain biking and road biking and running every day, and martial arts, I did years of Nisei Kitaru Jiu-Jitsu,
Kodokan Judo, Akijitsu, Aikido, Okinawan Karate, a little bit of boxing, like.
So when I wake up in the morning, I'm just like, oh no. But it finally really took a toll on my right hip, so I just have to get that taken care of. I know, too much information, sorry, but some of you were worried, so I'm not dying or anything. I'm going to go wake up, and then I'll come back and I'll shoot the conclusion segments of this video, edit it all together, and put this up later tonight. Now on to the footage from yesterday. Alright, so with no further ado, here are the things that haven't worked for me. Most certainly not all the things that didn't work, but I had to stop talking at some point in time. And bear in mind, some of these are going to be no-brainers, but there are a lot of newbies that come and watch these types of videos, so it could save them a lot of time and frustration. And the answer to just about everything in the world is like, can it work? Well, under certain circumstances, but I'll try to tell you the circumstances where my stuff worked or didn't. So let me just run down this list here. Pardon me as I have to look over at my list. Whoa. 3D printed GT pulleys. That's something that like I beat my head against for a long time, because I'm like, hey, back in the day, they used to be fairly expensive. Now they're really cheap. So, but in years gone by, it was common practice to use printed 3D pulleys, and they were never really perfect. I mean, obviously you can do it, and a lot of people have, but even compared to like the cheapies you can get these days, especially the GT profile stuff, it's not really worth it. But they are made of plastic and they're slippery, and the profile's never absolutely perfect. They're never like absolutely super like cut with a lathe and a CNC round, so Conclusion, man, these days just buy some cheap pulleys. It's not really worth the hassle. I'm sure there's some purists out there that are still printing them, but there are probably people still out there using their original Mendels, so whatever. This is something that works and doesn't work, like import parts from, like the AliExpress and the Banggood and things like that. And this is more of a note for the newbies who don't know what to expect with sites like this. Because it's not like some of the sites that you may be used to where you can trust the specs and you can just send them back if it doesn't work and that type of thing. Sometimes it works fantastically well and you get awesome things really cheap. Other times, it just doesn't really work out. And it seems to be like a 50-50 ratio of each. Now, here's the problem. Like when you're going to some place like, Mauser or DigiKey or something like that, or even like Robot Dig, they'll have a lot of the specifications. They'll tell you like exactly what materials are involved. They'll tell you the exact specs and all that type of stuff. But a lot of times when you're going on these big middleman importer type sites, the information is either very general, or it's a bad translation, or it's a copy paste from like a different ad, so you really don't know what you're getting. So it's sort of hit or miss. So that's not really a failure on, the part of the buyer or my part or something like that, but that's just to say that that's one of the big failure versus success things that affects the daily life of people that are in this sort of tinkerer situation. Kind of a no-brainer, but if you have somebody who can give you a link to like a known good product, that's great. Check out on the internet or whatever. Also, if it's not time sensitive and you can afford maybe getting not exactly the right thing once or twice, go ahead and do it. But obviously, if you're in a hurry or it's something that's vital that the specifications are correct, just pony up the extra dough and get it from a known source. Play in the linear rails. Let me grab a linear rail. I explained this in a live stream, and I don't know if this is a purposeful thing on the parts of these cheapy rails, or if it's just an artifact of poor machining and the wrong bearing sizes and things like that. But there's an ever so slight amount of play, like axial play here. That's enough that if you're using this alone for an axis, when you're printing at certain speeds, like for example, if the bed is on here and this is the only thing supporting it, that it rattles. So you hit resonance on your steppers and it makes print artifacts, which is not great. Also with the x-axis, that play was enough that on certain moves there was inaccuracy on the walls, so I wasn't super happy with that. I did a workaround for these on the printer that you'll see in the videos when they come out by just putting a V-slot wheel here and tensioning the bearings against it like this so that it's all nice and rolling flat on this one side and you don't have any movement. That worked really well, but it is like an extra step that was unnecessary, and that's not something I really would have known going into it, buying these. And it's sort of hit or miss with the cheap rails that you get. So I learned to get some that are slightly, have a slight preload on them, if I have that choice in the future. But again, I did buy these on budget blowout for $8.60 a piece or whatever they were. So I had no idea going into it. Lesson learned. Again, just like talking about the other import stuff, if it's like a known good link, that's cool. Go ahead and do it. The problem is sometimes they sort of rotate stock in and out of the same type of deal, but from different manufacturers. Like I said, if you can get them with a slight preload, that's good. If they have the right bearings in them, that's good. If you don't know what I'm talking about, check out my video on the cheapo linear rail. And if not, you can use a tension wheel like I did, and I'll give you details on that with the live stream printer build videos coming out. One of the other things on that printer, I tried, I used a 24 volt power supply, like a $15 really cheapy, Meanwell knockoff type deal. And they have a voltage adjustment on the feedback loop that controls the voltage of the regulator. There's a little potentiometer you can turn either up or down a few volts. So I had heard from the Prusa folks that they had a lot of success with the TMC 2130s running slightly higher than 24 volts, so I overvolted my supply a little bit to 27, 28. Unfortunately, the cheapy fans that I bought didn't like that very much, so that's another thing that I'll be aware of in the future, is those fans don't like being overvolted. Conclusion, surprise, surprise, 99-cent fans don't like overvolting. I mean, only one of my two failed, but if it's something that's vital, on your electronics, just be careful. NEMA 14 extruder. Yeah, I wanted to try a really lightweight extruder for this project, and I ended up with just like a standard weight extruder for this project. It's lighter weight than like a Wade's extruder, but initially this was designed, and I changed the gearing to the belted design, and I ended up using a NEMA 17 motor instead of a 14 because I did the math on paper and it seemed like I should be able to max out the capacity of a 0.4 millimeter nozzle, which I likely would have been able to do with a regular E3D V6 or like a sleeve hot end like a light, but I was hoping I could push it enough to work on a Volcano hot end. But that ended up not being the case. I kind of ran out of juice with the small steppers before I maxed them out. Now, if you were either not running a Volcano or if you were printing it like lower speeds or with a very fine nozzle, like you can get away with these tiny little steppers and that's fine. But high-speed prints running at full capacity, not so much. So volumetrically, you only want to put out like, let's say under like 10 millimeters cubed a second or something like that, this would have worked out fine. Now, this conclusion is, well, it depends. Obviously, you can use a NEMA 14 or a NEMA 11 or even a small DC motor stepper if you're using like a closed loop or something like that, and be fine if you don't need maximum throughput. What I was trying to do was make sure that I had the horsepower for the extruder to be able to cover the entire possible range with that nozzle diameter and a Volcano heater block, so it just didn't quite have enough to do that while being geared down 3-to-1. So under all of those conditions, didn't work for me, but in other situations, it's absolutely fine. Here's an older one. You know, if you watched my past videos, that I wanted to do like a 3D printer belt comparison contrast type thing, and I was planning to get like a regular belt, Gates belt, which is nylon faced and it has extra fibers inside that make it a little bit more stiff. I wanted to try that against like aramid reinforcement and you know, whatever they had, like Kevlar and fiberglass and all the different options, steel, but I couldn't get a hold of them, and I couldn't tell online exactly what the tooth profile was and which pulleys had to be made. It just ended up being a mess. And a lot of these places, they have a ton of these different types of belts that are like actually, you know, guaranteed and certified and all that, but you have to order ridiculous amounts of it. That didn't end up working out, and I just ended up being the cheap belt that you can get from, you know, Amazon or whatever, versus the white polyurethane belt with the steel reinforcements. I would have liked to have done more testing with like the diameter of the pulleys and that types of thing, but on the printer that I had at the time that I was testing with, the bend was too tight for it to be good, and the steel ended up like, you know, pulling apart and things like that, and the print quality wasn't any better. So anyway, that video ended up being incomplete, but I did so much testing, I ordered the parts that I was like, all right, well, I'm going to have to put this out anyway. But I did keep it around for future testing with maybe like Core XY or, you know, belted ZX stuff where you need something like pretty strong, so maybe it'll work out in the end. I can't conclusively say that they're not worth it because I haven't tried them in some situations where they might be good, i.e. like Z-axis, but just be aware that from my limited use of the generic type that I tried, the steel belts do tend to want to pull away from the plastic and fray, especially if you're making a tight bend with them. But I'm pretty sure that's a known issue by now. Okay, here's a completely off-topic thing that like didn't work out, and it wasn't something I really thought of ahead of time, but I should have. And that was taking a high voltage vacuum tube circuit and breadboarding it on like a standard breadboard. Now, of course, I know better than to put a lot of high voltage on those breadboards. They don't have great isolation and I don't trust them, but I kept the highest voltage out and then just kept the voltage that was knocked down by the plate resistors onto the board. So it was only like, you know, 150, 200 some volts or something like that. And I made sure to keep a couple rows of separation between them. And AC wise or DC wise even, like the voltage thing didn't end up being an issue, but the reason I wanted to put it on that breadboard was so that I could try a whole bunch of different options, like listen to it and see what I was happiest with. Usually I do that on like turret board or turret strips or something like that, and you have to solder and desolder all the different parts, or clip them on or something like that. But that's a lot of effort. You end up like wasting a lot of like resistors and capacitors if they you overheat them, or they get mangled when you're taking them on and off the turrets and that sort of thing. So I thought, hey, this is just part of a circuit. I'll do it on a breadboard. Bang, we're done. Well, I didn't anticipate exactly how much capacitance there was on the little clips on the board. So by the time that I took that, oh, and leakage from pin to pin. So by the time I took that and I transferred that into a regular setup, it didn't sound or behave anything like it did on the board, and I had to redo it on the turret boards anyway. This terrifying mess right here, which weighs a ton, but you see the circuit ended up doing on a turret board, parts of the power supply on just like little strips. This is like, a science fair experiment nightmare. Ugh. Big old transformers, etc., etc. Anyway, that was the guitar amp, and I've built dozens and dozens. But lesson learned. Conclusion, breadboards can lie. It's a known thing that breadboards have a lot of contact capacitance and resistance, and that they're not supposed to take a whole bunch of voltage. Usually they will have some kind of rating, but if they don't trust them for vital circuits. And most certainly don't trust your life to them when you're talking about high voltage, so be careful there. Let me see. Eddy current brake. Yeah, so as you know, for a long time I've been collecting various stepper drivers to do a big old torque and noise and accuracy comparison test in the future, just like I did with the TMC 2208s in a previous video. And that keeps getting pushed back for various reasons, mostly because these companies are getting savvy to the fact that 3D printer folks are using these and they want special features. Then Trinamic really upped the bar and they keep putting out new chips. So do other manufacturers. So we didn't have like the chips from like Sanyo and Toshiba back then in step-stick format. Now we do. So I keep having to order like more and more chips, and I have this box that's just growing in the number of chips that I'm going to eventually have to test. But the original jig that I did for that, I wanted to optimize the testing time that I did. So the original TMC 2208 stuff, to run like a single bank of tests without like separate noise tests and all that, took like an entire day, and I wanted to combine as many as possible. So if I could do the noise tests while I'm doing the torque tests, I thought that would be great. The problem is I was using a friction jig at the time, and that itself made a whole lot of noise. So it would throw off the measurements, and I would have to take that out and put it in a separate jig to do that test. So I wanted to use a contactless type of a braking system to test the torque, and I thought, well, eddy current braking is the way to do that. So I made this jig here that uses these kind of lightweight discs from a old salvage hard drive stacked together, and they have a magnetic goop on there. And then I resalvaged the neodymium magnets from in there, and the way that works is, if you don't know anything about eddy current braking, here you can see the disc spinning, and then the brake doesn't touch, but because of the eddy currents generated through Lenz's law and all that stuff, it will slow it down and turn that kinetic energy into heat. The problem is, if you know the math behind like all that stuff, the higher the speed, the more resistance you're going to get. So it didn't work out great at low speeds, and that tends to be where steppers are noisiest anyway. And Trinamic drivers, even when you're in like a stealth chop mode, they have to switch into spread cycle for certain things, and the microplier interpolation doesn't work at certain speeds and things like that. So it was vital for me to be able to test that noise at low speeds. So eddy current brake didn't work, and I had to redo the jig to use a friction brake at lower speeds, supplemented by an eddy current brake at higher speeds. So anyway, there you go. Another lesson learned. Conclusion, it depends on the speed. With thick enough discs and big enough magnets, sure, you could get away with it at lower speeds. It'll be more of a pain in the butt at higher speeds. I just chose to do like a hybrid, friction and eddy current type deal, which works for me, but just be aware that at lower speeds, not great. But that is a characteristic that you can exploit, the fact that they work better the faster they go. For example, like safety harnesses for climbing and that type of thing, so that when it's unreeling slowly, it doesn't really have any effect. But, you know, if you were to drop off of something, then the faster you go, the more it's going to cushion. So that can be used for various, uses in robotics as well. Here's an example of something that I just would not have ever thought of with... the live stream printer. I wanted to try to make the two axes, which are different weights, make them kind of top off before the steppers lost steps at roughly the same rate. So for the lighter axis, I used larger pulleys, figuring, hey, I'm not going to need as much holding torque for this, so I might as well use larger pulleys and even out the torque between the two axes, and that way I can save some computational, background work with the microcontroller in the process. Well, that didn't work out that great. I used 20-tooth pulleys on one axis and 30-tooth pulleys on the other axis, and I had all kinds of weird print artifacts and things like that. As soon as I popped it to 2020, that worked out fine. And I discussed this on like the live stream thing. I don't know if it's because of rounding errors in the libraries or whatever their truncation errors are, but when you put those values into Marlin, one of them ends up being integers, which 8-bit microcontrollers handle very well, and the other ends up being a float or a double, and they obviously have to be truncated and then re-estimated, and I don't know what math where that goes then in a planner and how vital it is for accuracy, but lesson learned. Keep them the same, keep them integers, and life works out well. Conclusion, it seems that this is a known-ish issue, or at least known enough that in the comments underneath the video where I mentioned this, some other people said, yeah, that's a thing. So just be aware of that if you have to use unequal steps between like similar axes like your X and your Y, that you try to use even ints, at least for now. Again, it may be some kind of artifact characteristic of the particular options that I had toggled on, so just be aware. Let me see what else we have. Oh, off-the-shelf inductive hot end. One of the things that I've been wanting to work with for a long time is an inductively heated hot end. I have built a couple like little rough samples that work or don't, but I have to tie that into like the regular PWM type control that comes from Marlin and things like that without having to write different firmware patches for control and whatnot. It seems logical to use the PID loop stuff and the type of control that's already in there, so you can just have like a drop in place sort of a thing. But in my early experience, I said, well, wouldn't it be great if it wasn't like a separate board that had to be made, but you could just grab one of these like ZFS, is that what it's called? Anyway, inductive hot ends that are, or inductive heaters that are, $7-8 on like AliExpress or eBay or whatever, and just do a control circuitry between them. That way you don't have to mess with like sourcing high voltage capacitors and cooling and all that type of stuff. Where is that thing? So yeah, I bought one of these little cheapies. These are the capacitors on the bottom. And real simple circuit, just a simple little self-oscillating circuit. And I just basically clamped this in a vise, ran a hot end through here, or not a hot end, just like the nozzle and heat break through here with the heat sink on the top, and manually hand-pushed filament through it, and tried to vary this by hand with voltage and other means to control the amount of heating. It worked very well for like 10 seconds, 30 seconds, something like that. And then this burnt out, whatever. That project obviously didn't work out. I wasn't going to put on a video, I did shoot some footage of it, and I was like, I'm going to put out a video that's like, this works great for 30 seconds. So inductive hot end, future project. Conclusion? Inconclusive. Obviously I did something that the board didn't like, and I plan on working with inductive hot end in the future. But as for just wiring up one of those like $7 units off the internet, didn't really work out that well for me. In the never know what you're going to get from overseas type of a train of thought, I have so many bags full of terrible bearings because a lot of times they don't give you the full specs, And then when they show the pictures of the bearings, these aren't the bearings that you end up with. So I ordered several different times little bearings for V-slot wheels and whatnot. The bearings that you get from open builds, they're very nice. They work very well. They're smooth. And as long as you have a shim in there, they take a decent degree of like preload before they start binding up. Well, these cheapies don't. They're crunchy. The metal shields on the side tend to like fall off. They're not lubed very well, and they take virtually no preload or axial load before they start binding. So I had to reorder those several times, and you know, every time you order from overseas, it takes like 4 to 6 weeks for it to get here. And as a result, I have several bags of 100 bearings and a bag of 300 somewhere that are just terrible and crunchy. And when you put them in the V-rails like this, even with the shim inside, you can't preload them very much because they just kind of bind up, and obviously that's no good. So yeah, now when I use bearings for those, I just get the decent ones for packs of 10. Bearings are one of those things where as they get better, they get exponentially more expensive, so it's better to look for the sweet spot in the middle zone than it is just to get like rock bottom stuff, especially if you're putting some kind of preload or axial load on them. And speaking of these V-wheels, something that I had hoped I could do but didn't really seem to work out was 3D printing them. So I tried 3D printing them solid. I tried printing them in 2 halves and gluing them together. And they just never seem to come out perfect. The way that those V-rails are made is they take a Delrin rod and turn it on a lathe, and they end up being very accurate and very smooth. But you always have variations when you're 3D printing. So I tried a couple different things, 3D printing them and then sticking them on like a drill lathe and trying to machine them down by hand so that they're nice and flat. And by the time I went through all that work, I was like, how much money am I really saving? These wheels are like $1.25 a piece. And if I have to print them and then go through this effort to make sure that they're nice and smooth and flat, it's not worth the effort. So that's another thing that never really worked out. Conclusion, this is another one of these things where it's best just to get the real deal. Plus the import wheels are good enough too. If that extra 50 cents a wheel for buying the real stuff is gonna break the bank. Now here's an example of like eyeballing something and it not working. I was planning a video on various types of 3D print reinforcement, and I'm still going to put that video out, and that'll work in a bunch of different, you know, technical measurement concepts, but I totally underestimated how much weight you can actually put on some of these 3D printed parts. So I had a bunch of these little like 60 millimeter guys printed out, and the thought was clamp this in a jig and then use a strain gauge with a pulley system to measure the failure point and the amount of deflection. So I have a depth gauge, and I was going to measure the amount of the deflection and then figure out the ultimate tensile strength and the Young's elastic modulus and all that type of thing of 3D printed parts in various orientations versus 3D printed parts reinforced in various ways, etc., etc. I still plan on doing that video, but what happened was this took way more force to actually bring it to the point of failure than I expected, and it exceeded the capacity of my strain gauges. And when they were printed in like you know, this orientation with the layers this way plus reinforcement, I mean, just something this small took over 500 pounds, which was my limit. So I have to retool that, get a stronger strain gauge, and mount up a stronger, you know, pulley system and things like that. So meh. Conclusion, dang, these parts can be strong, especially if you're going to use a secondary tension member like I do in a lot of my parts. But I will have a video on that in the future as soon as I get a new rig together. Safe solvents for PLA. As you know, PLA is very chemically resistant, which is nice. If you apply a little bit of basic high school chemistry, you can find out the stuff that dissolves it. But if you poke around online a little bit, you'll see that all that stuff is pretty nasty. Nasty enough that I was uncomfortable putting out a video and talking about it. So I thought I would go kind of think laterally and look for things that are a little less volatile and a little less toxic, and see if any of those worked out. Nothing really. The one that showed the most promise was various degreasers made from soy, but they didn't really work out all that well. Hopefully in the future I can find something, but until then, the only stuff that really dissolves this properly is this really nasty crap that sits here under this exhaust hood. Conclusion, I'm gonna keep looking. There's nothing definitive, but even the nasty stuff that you used to be able to get in just about every corner hardware store here in America, it just last month got banned for general consumer use, so it's getting harder and harder to find things that are, over the counter, so to speak. So the search goes on. Just a couple more things. One is that if you've heard of Clipper firmware, it's a clever firmware that uses a general purpose CPU for doing computations, which they are good at, and then spits that out to a microcontroller unit, which actually does like the steps, sending them out to the stepper motors and things like that. So you can get like ungodly high step rates with 8-bit boards, because you're not doing any math on it, which they're not great at. But it requires the use of networking things together and a separate processor board. So I thought, well, the cheapest way to go is like a Raspberry Pi Zero, because they're like $5 or like $6 for the Zero Ws. But Clipper relies on Octoprint, which is not great with those, particularly if you're trying to shoot video at the same time. If you're not trying to shoot video, it's fine. That is compounded by the fact that many people use Windows, and Windows virtual USB driver is extremely bad at very small bits of information being sent. So not even bits. So if you're sending 4K, these tiny little characters over the virtual USB port, there's a massive ton of overhead in Windows drivers, and it's not terribly efficient. So that was a pain in the butt. But you can run Linux on these little Raspberry Pis. Those virtual drivers are like 250 or so times faster for small packets than Windows, and then Mac OS you can't run on these boards, but it's even better than Linux, at least under my tests. So I thought, well, let's look for a more powerful substitute, because a lot of people would want to use the webcam and Clipper if they're using Octoprint anyway. So I got some of these Banana Pis, and they are like Raspberry Pi Zero done right. They're only slightly more expensive, but they overcome one of the problems with the Raspberry Zero, because they have an external antenna jack right here. And as you all know, if you use the Pi Zeros, the Wi-Fi reception is not great, and you have to kind of angle them properly and make sure you have line of sight if you want them to be consistent. They also have a quad-core, an all-winner H2 Plus processor, like you would see on old, Android cell phones and things like that, as opposed to the single core processor that's on the Pi Zero. So specs wise, I was like, well, maybe this will be good enough. It'll have the horsepower and the network throughput to be able to do this. But getting Clipper and Octoprint to play nice with this proved to be a little bit of a pain in the butt. And I had to do a custom Raspbian build, the Raspberry Pi version of Debian build, and jump through a whole bunch of hoops, and then set up the things on top of that and jump through a whole bunch of hoops. And I was screwing around in the command line on an unfamiliar operating system for a lot of people is not optimal. So that's probably not the path that I want to take, unfortunately. I still want to give this another go, because I think it's a good alternative, but just using like the regular Pi Zero plus the virtual SD card on Clipper overcomes a lot of problems, and if you don't use a camera, it's just fine. So that may be the option that I go with in the future when I actually start doing videos on Clipper, which is after I get this stuff out of the way. Conclusion, you can get it to work, but you have to build it from scratch yourself. Right now, I'm not sure if anyone's done like a pre-rolled image of like a current version of like Raspbian that you can just sort of flash the image over. But there is always the option of using a Zero with the virtual SD card and that type of thing. Thanks for tuning in. Hope that was kind of fun. Feel free to start a discussion down below in the comments if you've actually gotten some of this working properly, what some of your fixes are, and you want to share with the community. That'd be great. I'll be getting some real videos out soon. We do have holidays coming up here, so it's going to be a little bit spotty, plus I have a couple more doctor things to go through. But at least I have the hard drive thing fixed. So until the next video, get out there and make something awesome.